welcome to day 5 of probability. Today we are going to talk about the binomial theorem. So this is ready to go. Alright, we need to expand x plus 3 to the third power. Okay, what that means is write it 3 times. Okay, I can only multiply 2 sets of parentheses at a time, so I will do the first 2. And when I do the first 2, I get x squared plus 6x plus 9. Okay, I've already combined my like term. And now I need to take and multiply that by x plus 3 again. So x times x squared is x cubed. X times 6 is plus 6x squared. X times 9 is plus 9x. 3 times x squared is plus 3x squared. 3 times 6x is plus 18x. And 3 times 9 is 27. And then I have to combine my terms, so I get x cubed plus 9x squared plus 27x plus 27. Now, would you like to expand x plus 3 to the 8th the same way? I know I would. So, there is an easier way to do this, and this is what the binomial expansion is. Okay? If I take x plus y and raise it to the 0 power, I get 1. If I have x plus y raised to the first power, I get x plus y. If I have x plus y to the second, I get x squared plus 2xy plus y squared. If I have x plus y to the third, I get x cubed plus 3x squared y plus 3xy squared plus y cubed. And I keep this up, and this is the pattern that I will get. And I have some observations when I expand x plus y to the end. There are always n plus 1 terms. So n is my exponent. If I go back and I look, this is 0, I have 1 term. This is 1, I have 2 terms. 2, I have 3 terms. 3, I have 1, 2, 3, 4 terms. So I always have one more term than my exponent. The first term of the binomial has decreasing power starting with n and continuing down to 0. So let's look at this one here. So my first term is x to the 6th, 5th, 4th, 3rd, 2nd, 1st. I don't see it here, and anything to the 0 power is 1, so you wouldn't write it down. The second term of the binomial has increasing power starting with 0 and continuing to n. And I don't see y to the 0 because it's 1. Y to the first, y to the second, y to the third, y to the fourth, y to the fifth, y to the sixth. Okay? Notice that the exponents always add up to n. N is our original exponent. So all of these exponents added up always add up to 6. 6 plus 0 is 6. 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. 2 plus 4 is 6. 1 plus 5 is 6. And 0 plus 6 is 6. Okay? Each term is separated by a plus or minus sign. If x minus y to the n, they would alternate. if it was x minus y, minus instead of plus, they would alternate signs in this case. We go positive, negative, positive, negative, positive, negative. And to determine the coefficients, we actually use what's called Pascal's triangle. Okay, Pascal's triangle has one on the outside. Okay, so to make Pascal's triangles, we have ones down the sides of the triangle, and then we add the two above it. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Okay? So, each entry is the sum of the two entries above it. Okay? So next, I want to find the next row. I always start with 1 on the outside. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. And 1 plus 6 is 7. And then we have to end with a 1. So that's the next row. Then I want you to find x plus y to the 7th. I'm going to do it down here. That would mean I'd have x to the 7th, y to the 0, plus 7, x to the 6th, y to the 1st, plus 21, x to the 5th, y to the 2nd, plus 35, x to the 4th, y to the 3rd, plus 35, x to the 3rd, y to the 4th, plus 21, x squared, y to the 5th, plus 7x, y to the 6th, plus y to the 7th. Now, there is one more thing that Pascal's triangle is related to that we really kind of need to know. And this is 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, and 7C7. Pascal's triangle is all of our combinations. Okay? So, like here would be 6C0, 6C1, 6C2, 6C3, 6C4, 6C5, 6C6. Okay, Pascal's triangle has a lot of neat things in it that you don't always see, but for right now, these are the important features that we need to know. So let's try and find some expansions here. This is the formula that you use. Kind of long and drawn out. Sometimes I think it's just easier to remember the pattern of the numbers than it is to actually try to remember a formula. So we need to remember that NC0 is 1, NCN is 1, NC1 is n, and NCN minus 1 is also n. It's just helpful when we're doing this. Now, remember how I asked you if you wanted to find x plus 3 to the 8th power? Well, we're going to try to find x plus y to the 8th power. I'm starting out, and I'm just way over here. There's lots of room. I will start out with 8c0. My first term is x to the 8th, y to the 0, plus. Next term has to be 8c1, x to the 7th, y to the 1st, plus 8c2, x to the 6th, y to the 2nd. Notice my exponents are always adding up to 8. My x term is always decreasing. My y term is always increasing. Unlike in the probability questions, r was matching the first term. This time r matches second term. Right, my next term is 8c3, x to the 5th, y to the 3rd, plus 8c4, x to the 4th, y to the 4th, plus 8c5, x to the 3rd, y to the 5th, plus 8c6, x to the 2nd, y to the 6th, plus 8c7, x to the 1st, y to the 7th, plus 8c8, x to the 0, y to the 8th. Wow, that's a lot of terms. We should have one more term than we have a power of our exponents. We should have 9 terms. Okay? And then I'm going to go through and calculate everything. All my combinations I'm going to get right off of my calculator. Okay? So here, 8c0, anything c0 is 1. So this is 1, and this is also 1. Anything to the 0 power is 1. I get x to the 8th, plus 8c1 is 8, x to the 7th, y to the 1st, plus 8c2 is 28, x to the 6th, y to the 2nd, plus 8c3 is 56, x to the 5th, y to the 2nd, plus 8c4 is 70, x to the 4th, it's actually 30, y to the 4th, plus 8c5 is 56, x to the third, y to the fifth, plus 8c6 is 28, x squared, y to the sixth, plus 8c7 is 7, x, y to the seventh, plus 8c8 is 1, x to the 0 is 1, so this is plus y to the 8. That is a lot of work to expand that, but it's not difficult work. It's just repetitive work. Okay, for number 3, we have 3a minus 2 to the third power. I could sit here and multiply it all out, or I can use my formula, my expansion. I should end up with 4 terms in the end. So let's try this. It'll be 3c0. This time I have 3a as my first term, so I'd say 3a to the third. The negative goes along with the second term, so it's minus 2 to 0, plus 3c1, 3a to the second, negative 2 to the first, plus 3c2, 3a to the first, times negative 2 to the second, plus 3c3, 3a to the 0, negative 2 to the fifth. Make sure all my exponents always add up to 3 as I'm going along, and then I can calculate this. 3c0 is 1, 3a to the third would be 27a cubed, negative 2 to the 0 is 1. 3c1 is 3, 3a squared is 9a squared, negative 2 to the first power is negative 2. 3c2 is 3 times 3a to the first is 3a, negative 2 squared is 4, plus 3c1 is 1, 3a to the 0 is 1, negative 2 to the third is negative 8. Then we just clean up and multiply in individual terms, and we end up with 27a cubed. 3 times 9 times negative 2 is negative 54a squared. Three times 4 is 36a, and then minus 8. We are actually going to skip number 4 because it's just repetitive. And we can always expand anything out the entire way, or we can find just specific terms. Now there is a formula. I don't think it's worth memorizing the formula. I actually think it's easier just to kind of figure it out. So find the fourth term of a plus 2b to the fourth power. I should have 5 terms. Okay? So if I have 4 terms, so 1, 2, 3, 4, 5, I want to find this term right here. It should be 4c0, 4c1, 4c2, 4c3, a to the 4, 3, 2, 1, 2b to the 0, 1, 2, 3. Remember, they must add up to 4. So 4c3 is 4, A to the first is A, 2b to the third is 8b cubed. Multiply everything all together, and end up with 32ab cubed. And this is my answer for that one. Find the middle term of 2r minus 1 to the 6th power. Okay, if I have a 6th power, I'm going to have 7 terms. So 1, 2, 3, 4, 5, 6, 7. And my middle term is 1, 2, 3, 4. That term there is what I'm looking for. So it is 6c0, 6c1, 6c2, 63. 2r to the 6, 5, 4, 3. Negative 1 to the 0, 1, 2, 3. And something that happens only when you have middle terms is your exponents will be the same. So 63 is 20. 2r to the third is 8r cubed. Negative 1 to the third is negative 1. So negative 1 times 8 times 20 is negative 160. R to the third. Okay. Last one. Find the last term of a minus 5x to the 5th power. So it means I'll have 6 terms. 1, 2, 3, 4, 5, 6. So we're finding the last term. So it's going to be 5C5, A to the, well, let's think about it. 5, 4, 3, 2, 1, 0. And then negative 5x to the 0, 1, 2, 3, 4, 5. So I will have 1, 5 is 0. It's 1, sorry. A to the 0 is 1, and negative 5 to the 5th is negative 3,125 x to the 5th. So my answer is negative 3,125 x to the 5th. Okay? If you have any other questions for me, make sure you ask me in class. Right now, I have you scheduled to spend 2 days on this topic. We shall see how it goes in class. You may end up moving your test to Thursday instead of Friday, but I will let you know for sure if we're going to do that. If not, then our test will be on Friday. Okay? Good luck with this, and we'll see you in class.